Assalamualaikum and welcome to the video. I am Aziman bin Abu Bakar here from Physics Unit KMPK. In this video, we are going to go through Experiment 6, Thermal Equilibrium. What we hope you to get from this video is that you can appreciate the practical session in facilitating your learning of physics, hence making the learning meaningful. Because some of the apparatus might be foreign for you. We introduce them in the video. Reading the procedure with no background knowledge could be confusing and intimidating. So we go through the setup process for you and we hope the procedure will make more sense to you. We are not going through the procedure step by step, but rather we are giving you the overview of the experiment and great tips to help you with experiment. Make sure you have with you the lab manual and open them to page 22 on the experiment of thermal equilibrium. And also, you are going to need your jotter to jot down important information and tips as you go along with the video. Before going to the lab session, make sure you have the objective, a brief summary of the procedure, and table for data collection ready in the jotter. You can also add sketches as a visual tool to help you with the procedure. It does not need to be perfect or beautiful, just keep it loose. In this experiment, we are going to determine the thermal conductivity of glass. For the theory, we have equation of dq over dt equal to negative Ka dt over dx, which is dq over dt is the rate of heat flow, K is the thermal conductivity, A is the tangential surface area for heat flow, dt over dx is equal to the temperature gradient, and the relationship between temperature and time is given by the equation log T naught minus log T equal to Kt over Brx. We rearrange the equation so we get log T equal to negative Kt over Brx plus log T naught. Next, we will discuss about the graph. From the equation that we have established earlier, we can plot a graph of log T against time. If we compare the equation with the straight line equation, log T will take the y-axis and time T will take into the x-axis. And the value of C is equal to log T naught. We will get a straight line graph and the gradient is going to be negative. The graph should have y-intercept of log T naught. When plotting your graph, make sure that the graph occupy at least 80% of the graph paper. Coming back to the straight line equation, the gradient of the graph will be equal to negative K over Brx. Choose 2 points on the line and draw a right angle triangle connecting the 2 points. Make sure the size of the triangle at least 50% from the size of the graph. The gradient of the line can be calculated using the equation m equal to y2 minus y1 over x2 minus x1. And the value you get from the calculation will be equal to negative K over Brx. Then rearrange the equation to become K equal to negative Brxm. Next, substitute the value of B equal to 4.84 times 10 power of 6 joule per meter cube per Kelvin, R radius of boiling tube, and X for the thickness of the boiling tube, and then calculate the value of K. You are going to compare the value obtained from the graph with the theoretical value of thermal conductivity of glass. Before we continue to the procedure, I want you to pause the video, open the manual and go to the procedure section of the experiment. After you have read through the manual, you can come back again to the video. If you have read the manual, these two statements will make a lot of sense to you. In the experiment, you are going to stir the ice-water mixture and warm water simultaneously, and then record the time taken for the ice-water mixture to drop from 30 degrees Celsius to 3 degrees Celsius. Finally, before going to the apparatus and setup video, we are going to present you with the table for data collection. Repeat each set at least twice and find the average. Make sure to enter the uncertainty for your measurement in the measurement column. Make sure you write the calculated value with the correct SI unit. Let's go to the apparatus and the setup. First of all, we will use a boiling tube and make a marking with 1 centimeter gap on the tube. We use mercury thermometer to measure the temperature. A 2000 ml beaker for ice-water mixture. A 400 ml beaker used as an ice scoop. A stirrer to stir ice-water mixture. Set of cork stirrer for boiling tube. A stopwatch. A vernier caliper used to measure the internal and external diameter of boiling tube. Retort stand with a clamp. An ice box for ice storage. And kettle to boil the water. We have a box of ice and put the ice into the beaker. Pour water until it becomes full. Therefore, it will become water-ice mixture. We use stirrer to stir the water-ice mixture. Make sure the boiling tube have been labeled with 1 centimeter gap. Clamp the boiling tube with the retort clamp. Pour hot water into the boiling tube until the water level reach the first marking line. Insert the thermometer into the cork until it reach the 0 degree scale. Insert the cork, thermometer and stirrer into the boiling tube and make sure the connection is tight. Drag the boiling tube set upward. Put the beaker with ice-water mixture below the boiling tube set. Lower the boiling tube set until the level of water-ice mixture reach the second marking line. Stir the ice-water mixture and warm water simultaneously. Record at regular time and the corresponding temperature starting from 30 degrees Celsius until it drops to 3 degrees Celsius. The ice-water mixture in the beaker and the warm water in the boiling tube should be constantly stirred throughout the experiment.